Hi, this is Mr. Singh here. Today's lesson is on black body radiation, which is part of the AQA physics syllabus. Before we do that, quick retrieval. I want you to think about this one. Why do you think homes in hot countries are generally painted white? And why do you think people in the middle of summer tend to wear light colour clothes, and particularly white? Pause the video and see if you can answer these questions. Okay, well, I'm hoping during the course of this video you will find the answer to the two questions there. You can see the three objectives. So the keywords: black body, atmosphere, emit, temperature, and radiation. So let's move on. I want you to think about this. What is the best colour to absorb electromagnetic radiation, to emit electromagnetic radiation, and to reflect electromagnetic radiation? Think about these. And you will, through the course of this video, find the answer to all three. So we need to think about, well, what is a black body? A perfect black body is an object that absorbs all of the EM radiation that hits it. They're only theoretical. You won't really meet a perfect black body. And this picture explains what that previous slide was talking about. You can see the radiation of possible wavelengths. The perfect black body absorbs every single wavelength. No wavelengths are reflected or transmitted. So we need to look at absorbers and emitters. We did talk about 2 or 3 slides ago about which colours being the perfect absorber and emitters. Well, let's have a look at this. A good absorber is also a good emitter. Emitters, that means it gives out thermal radiation. Absorbers takes in thermal radiation. So remember that. Good emitters of heat energy are also good absorbers. So if you look at this, you've got a spectrum of all colours. You've got, starting with matte black, and then you'll have all the other different colours in there, leading to white, and then ending with silver. And you can see matte black will be the best emitter, whereas silver will be the worst emitter. So I've got a question for you. Some people prefer to have silver radiators in their home. Do you think that's a good idea? If it's the worst emitter? And if matte black is the best emitter, what colours should the radiators really be? You then move on to reflectors. Matte black is the worst reflector, whereas silver is the best reflector. That's why they have these silver-lined aluminium foil blankets for anybody that gets injured. Or if anybody's cooking a turkey, the aluminium foil is a shiny silver because it reflects the heat back in. And then absorbers, matte black is a very good absorber. Like I said previously, a good absorber is also a good emitter. So matte black is a good emitter, which means it's also a good absorber. The silver is the worst. And there's the answer to the first question in retrieval. In hot, sunny countries, houses are often painted white to reflect the heat and keep them cool. Something else on here, you may have noticed that most aeroplanes are painted white. Well, that's the reason, so they can reflect the sun's rays. Emitters. All objects emit EM radiation. The amount varies with the temperature of the object. Now, this EM radiation is mainly infrared radiation. However, they also emit other EM radiation of varying wavelengths and frequency. The intensity, this is the power per unit. Now, one thing you need to remember, as temperature increases, the intensity of every wavelength increases. This means more energy will be transferred in a certain period of time. And you would expect that. As temperature increases, more energy will be transferred. Now, as an object gets hotter, the peak wavelength actually decreases. The peak wavelength of the EM wave decreases. And this can be shown in the graph. You can see at 6,000 Kelvin, the wavelength is decreasing. And again, you can see in this graph, 3,000 Kelvin, the wavelength is decreasing. 3 questions here. You can pause the video here. Let's have a quick 3 review questions. Okay, so let's move on. On Earth, radiation from the sun is made up of various wavelengths. Some of these are reflected back into space by the atmosphere, clouds, etc., while some are absorbed by the atmosphere, and it keeps the Earth in a nice warm condition. Now, the Earth's temperature depends on the rate of absorption, reflection, and emission. Now, during the day, more is absorbed than emitted, so it feels warm. At night, more is emitted than absorbed, so it feels colder. And then there will be a couple of required practicals we have to do here. Now, the first one is where we have a Leslie cube and we fill this up with boiling water. Now, each surface, you can see, is painted different colours. You have a black phase, a white phase, a silver phase. And you have a thermal radiation detector that compares, basically measures the amount of heat energy being emitted from different phases. What do you think? Which phase do you think will emit the most? Right, okay, I hope you said black, because in the previous slides we did say black surface, matte black is the best emitter. Move on. This one is where we are measuring, we have a radiator, we have thermometers are attached to the rear of 2 metal plates, and thermal energy from the radiant heater is then absorbed by the 2 plates, and the thermometers help us to assess which colour is the best absorber. Which colour will be the best absorber? In other words, which thermometer will show a higher reading? Okay, I hope you said black. As you can see from here, you can see black is the best absorber. Moving on. Here's some past questions for you to have a go. The diagram shows the design of a solar cooker. The cooker heats water using infrared radiation from the sun. So you can see that. Pause the video and have a go at these 2 questions. Why is the inside of the large curved dish covered with shiny metal foil for 1 mark, and B, for 2 marks, which would be the best colour to paint the outside of the metal cooking pot? Pause the video and have a go at these. Okay, let's have a look then. So, to reflect, that's the answer for 1 mark. Accept shiny surfaces are good reflectors. Ignore any reference to incorrect type of wave. And then for 2 marks, it would be black. And why? Because it's the best absorber. Moving on. Here we go. Why does the cooking pot have a lid? And then D is a calculation, be worth 3 marks. So you can have a go at this, pause the video. Okay, so let's have a look. There you go, to reduce energy loss. It's a simple answer. And for D, there you go. Okay, now this is the equation, just in case you're wondering where the answer has come from. This is where you're going to use, it says calculate how much energy is needed to increase the temperature. So it's mass times the specific heat capacity times change in temperature. So the mass is 2, specific heat capacity is 4,200, and the change in it says here, increase the temperature of 2 kilograms of water by 80 degrees. And that should give you the answer. And obviously energy is measured in joules. Moving on. And that's the end of this lesson.